Okay, so for lesson 4, we're going to relate side lengths with the number of tiles on a side. So we're going to be working with rectangles again, but we're going to be looking at the side lengths today to help us find the area. So for this first one, I just want you to take a look at it. You don't have to draw or do anything. But we've got rectangle A and rectangle B. Over here to the side, it says I use 15 square inch tiles to make both of these rectangles. And you can see that both of them have 3 rows of 5, so that's 15 tiles that they've used. Is the area of both rectangles 15 square inches? Well, we've learned that whenever we are finding the area, if we count all of the squares in that rectangle, that's going to tell us what the area is. So if they both use 15 square inch tiles to make these rectangles, is the area of both of them 15 square inches? I hope that you're thinking to yourself, no. I know that they use 15 square inch tiles, but there is something wrong with both of these rectangles to make the area not 15 square inches. I want you to think about what's wrong with rectangle A and what is wrong with rectangle B to make the area not 15 square inches. We've talked about this before when we're working with our tiles in our bagging. This one up here, the problem is that all of these squares are not together and there's too many gaps in between them. If I were laying a floor in my kitchen, I would not put all of the floor like this. I wouldn't have all these big gaps in between the floor pieces that I'm putting down in my kitchen, because then it would look really weird. So you can't find the area when there are gaps in between your pieces. This one down here, rectangle B, the problem is that they overlapped them. Once again, if I was laying floor in my kitchen, I wouldn't put a piece of floor down and then I wouldn't put another piece on top of that, because then I wouldn't be able to walk on my kitchen floor correctly. So when we're trying to find the area, there can be no gaps in between our squares and they cannot be overlapping. They have to be right beside one another with no gaps and no overlapping. And it says, why is it important to avoid gaps or overlaps when we measure area? Well, I kind of just explained that whenever I was talking about the kitchen floor. You wouldn't want to have gaps in your kitchen floor, and you wouldn't want to put floor pieces on top of floor pieces, because then it wouldn't be flat. So what we're going to do is we're going to need 15 of your square inch pieces, so those bigger squares in your baggie. So I would like for you to go ahead and take 15 of those out of your baggie and push play once you have them out. Okay, so what you're going to do is that you are going to create a rectangle with the area of 15 square inches. So let's think about what multiplication equation is equal to 15. I don't want you to think about 1 times 15 or 15 times 1. I want you to think of the other equation that you can multiply and get 15. Write that down on your piece of paper for me, the equation that is equal to 15, and push play once you have it. Okay, so I hope that you wrote down 3 times 5, or if you switched it around, you wrote 5 times 3. So either way, it's fine with me, because we know that whenever we count by 5s 3 times, we get 15. So let's use this equation to help us create our rectangle. So usually sometimes it's okay to think of a rectangle when we're working with area as an array, because whenever we have these squares, we have so many rows and there's a certain amount of number of squares in each row. So let's look at 3 times 5. That tells us that we're going to have 3 different rows, and each row is going to have 5 squares in it. So first thing I want you to do is I want you to make a row of 5. Remember, put them right beside each other, not overlapping, and with no gaps. And once you've made your row of 5, then you need to make 2 other rows of 5. So that way we can have 3 rows of 5, so that our rectangle will have an area of 15. So put this out in front of you. You can put it on top of your paper on your desk somewhere, but I want you to use those 15 square inch pieces and make 3 rows of 5 to show a rectangle that has an area of 15 square inches. So once you have all your 15 pieces laid out, you can push play. Okay, so this is what it should look like in front of you. Okay, so let's say that we did not know that the area of this rectangle was 15. They did not tell us that. And we didn't even know this. I'm going to take away these multiplication equations. But they did tell us what the side lengths of it was. So I'm going to put 3 right here, and I'm going to put 5 right here. And I really need to put inches since that's what we're working with. Okay, so if we did not know what the side length, or I'm sorry, if we didn't know what the area was, but we knew the side lengths, all you have to do with those side lengths is multiply them. When we're working with area, if you know the side lengths, you multiply. So I really want you to remember that, because that is going to be a really easy way for you to find the area, because we do not have to count each one of these squares. You just multiply the side length. So this side length is 3, this side length is 5. So to find the area of this rectangle, we do 3 times 5 and we get 15 square inches. So sometimes in this module, you're going to see some pretty big rectangles that have tons of squares in them, but we do not need to count all of the squares. All we have to do is find the side lengths, and that will tell us the area. Okay, moving on. Same square here. It says, what is the relationship between the number of tiles on a side and the side length of the rectangle? Well, on this side, there are 1, 2, 3 different tiles, and the side length was 3 inches. This side, there was 1, 2, 3, 4, 5 different tiles, and the side length was 5. So that tells us that however many tiles or pieces of squares there are on the side, that's what the side length is going to be. So those numbers are exactly the same. And then it says, what do you notice about the lengths of the opposite sides of the rectangles? So if this side was 5, and we look up here, we still see 1, 2, 3, 4, 5 as well. That tells us that these two opposite sides of the rectangle are the same. And then right here there were 3, and over here on this opposite side there were also 3. So these two opposite sides of the rectangle are also equal. Okay, so you can put those 15 square inch pieces to the side, and now we're going to make a rectangle that has the side length of 5 centimeters and 4 centimeters. So let me just show you what this is going to look like. Here's a rectangle. One side is going to be 4, and one side is going to be 5. So we just talked about, if we know the side lengths, it's a big old line, if we know the side lengths, then all we have to do is multiply them to tell us what the area is. So for this one, we don't know the area, so we don't know how many squares to take out, but we do know the side lengths. So if we multiply 4 times 5, then we will know the area, and we will know how many square centimeters to take out of our back. So multiply 4 times 5 to see what the area of this rectangle is going to be. 4 times 5, you know how to count by 5, so I hope that you got that it was 20. So in your baggie, you're going to be taking out 20 of the square centimeter pieces. So go ahead and do that, and then push play once you have all of those out and ready. Okay, so if you should have out your 20 square centimeter pieces. So since we know that we're going to have 5 in a row, we can start by putting 5 square centimeter pieces right beside one another to make a row of 5. And since we know that one other side length is going to be 4, we know that there's going to be 4 rows of 5 to help us make our rectangle that has an area of 20 square centimeters. So what I want you to do with your square centimeter pieces is make your 4 rows of 5. Make sure you're putting them right beside one another and they're not overlapping on top of each other, or that there's not any gaps between them. And once you have used all 20 of your square centimeter pieces and you have your 4 rows of 5, you can push play so we can move on. Okay, so this is what your rectangle should look like in front of you. I'm going to label the side lengths. This side length is 4 centimeters and the other side length is 5 centimeters. So once again, I'm going to say this over and over again because I want you to remember it. If I were to multiply these side lengths, that would tell me the area of this whole rectangle. This whole rectangle has 20 of those squares, and 4 times 5 was 20, so the area of this rectangle was 20, not just 20 centimeters, but 20 square centimeters. So multiply the side lengths to find the area of rectangles. Okay, so now we're ready to move on to the problem set, so you can put your squares back into your baggie and then turn to the problem set in your binder. Once you have all that ready, you can push play on the video. Okay, so once again, we are not using the actual problem set paper for this, so you'll probably see where it says homework at the top of the page, but I liked this page better than the problem set page. So number 1 says Ella placed square centimeter tiles on the rectangle below and then labeled the side lengths. What is the area of her rectangle? So I don't want you going and counting every single one of the squares in this rectangle. We just learned in the concept development that if you multiply the side lengths, that gives you the area. So over here on this part of the paper, I want you to put the equation that we're going to be using to find the area for this rectangle. So if one side length is 2 and the other is 4, we know that all we have to do is do 2 times 4, and that will tell us the area for this rectangle. We all should know that 2 times 4 is equal to 8. Okay, so all we need to do now is write the total area for this rectangle down right here. Okay, so hopefully we've gotten used to not just writing the number. We cannot just write the number. We also have to put square centimeters with it. So on your paper you should have down 8 square centimeters. Moving on to number 2. Okay, so this one says Kyle uses square centimeter tiles to find the side lengths of the rectangle below. Label each side length and then count the tiles to find the total area. So we're not going to do this part because that is not the best strategy to use. Once we have found the side lengths, we're not going to be counting all of those squares. We're going to multiply the side lengths. So this top row has 1, 2, 3, 4, 5. And since it said that he was using square centimeter tiles, then you need to abbreviate centimeters right beside the 5. So this side length was 5 centimeters. This one has 1, 2, 3, 4. So this side length is 4 centimeters. So now that we know the side lengths, all we have to do is multiply the 2 side lengths to help us find the area instead of counting all of the squares. So I want you to multiply those 2 numbers to find the area, and then I want you to write the total area on this line, and once you have that done, you can push play. Okay, so 4 times 5 is 20, so that tells us that the total area of this rectangle is 20 square centimeters. I hope that you put the square centimeters down on your paper. Okay, now moving on to number 3. This one, she used square inch pieces to find the side lengths of the rectangle below. It says label each side length and then find the total area. So we've got 1, 2, 3, 4, 5, 6, 7 on this side. she's using square inch pieces, so we've got to put inches next to our 7. And then this one just has 2, so that's going to be 2 inches. So we're going to do what we just did on the previous 2. I want you to write the equation down here at the bottom where we are multiplying the side lengths to find the total area. And once you have multiplied that, I want you to write the total area on this part of your paper. And once you have that done, you can push play to check it. Okay, so you should have done 2 times 7, and that was equal to 14. So the total area for this rectangle was 14, whoopsie, that doesn't look like a 4, square inches. Well, my goodness, it's hard to, oh man, I gotta rewrite the whole thing. Okay, maybe I can make this a little bit better. 14 square inches. It's hard writing with this on the computer. Okay, let's move on to the back side. Each square unit below is 1 square inch. So each one of these is a square inch. Claire says that the side length of the rectangle below is 3 inches, and Tyler says that the side length is 5 inches. Who is correct, and explain how you know? So what we need to do first is we need to find the side lengths of this rectangle. We don't have to find all of the side lengths because we learned in the previous or in the concept development that if I know this side length, the other side length is the same. Okay, and when we're finding the area, all we have to do is multiply the 2 side lengths instead of all 4 of them. So if we know the length and the width of the rectangle, which is each side length, we do not need to know all 4. So let's look at this top row. We've got 1, 2, 3, 4, 5 different squares. So we know that this side length is 5 inches. Whoopsie, hold on. And then down the other way, we've got 1, 2, 3 squares. So this side length is 3 inches. So looking back up at the problem, it says Claire said that the side length is 3 inches, and Tyler said that the side length is 5 inches. So Claire was right for this side, and Tyler was right for this side. So the answer says, who is correct, and explain how you know. Well, we know that one side length is 5 inches, and we know that one side length is 3 inches, so they are both correct because one side length is 3 inches, and the other side length is 5 inches. So they are both correct. All right, moving on to the last one. It says label the unknown side lengths for the rectangle below, and then find the area. Explain how you use the links provided to find the unknown lengths and area. So we learned in the concept development that the opposite sides of the rectangle are the same size. So if this side is 4 inches, that tells us that this side right here is also 4 inches. And I'm just going to put IN to abbreviate it. If this side is 2 inches, this side is also 2 inches because we know that the opposite sides of a rectangle are the same. So if it says explain how you use the links provided to find the unknown links, we found this number and this number because we knew that opposite sides of a rectangle are the same. So over here to the side, I found the unknown links because opposite sides of a rectangle are equal. And I always want you to remember that. Opposite sides of a rectangle are equal, so that's how we were able to find these unknown numbers. Now, like I said just on the previous problem, I'm not going to multiply 4 times 2 times 4 times 2 to find the area. I just multiplied these 2 side lengths to find the area. So once again, we're going to write our equation like we have been. 2 times 4 to find the area of this one. Since it says inches, We know that we're going to be putting inches when we're writing our total area, so it's not just 8, it's 8 square inches. Okay, so now we are finished with the problem set and you are ready to move on to the exit ticket, which is very super simple because all you have to do is label the side links. So each one of these is going to have 2 numbers written on it to label the side links. Notice that some of them are using centimeters and inches, so I don't want to just see the number when you're labeling the side length. I also want to see inches and centimeters. And then once you've labeled the side links, you draw your line to the correct area that it matches. So once you have this done, you may bring it to me and we'll check it.